area under a curve, and then slope of a curve. So we did derivatives whole first semester and found the slope of all kinds of curves, natural logs, everything. So now, if we have a curve like this from here to here, we're going to be able to find the area under the curve. And what's really crazy, by the time we hit unit 8, we'll revolve this curve around the x-axis to make a solid and find the volume of that solid. Yeah, fun stuff. And you go, why? Well, fluid dynamics, okay? Those people who go into the engineering and use hydraulic cylinders and that have to know the amount of fluid that's pushing through and the volume and the pressure involved and all that, so they don't blow out the cylinder and all that. All these engineering types need to know this type of calculus. So, yeah, so that's what we're doing. Now we're going to start with some very basics of area under straight lines and angles. Okay, so we can help find area under curves. So look at this. A snowstorm lasted 24 hours. That's how that happened to be the very first example. Who knows? So snowstorm lasts 24 hours. The graph below shows the rate of snowfall as a function of time. How much did it snow? How many inches of snow did we get in this snowstorm? Okay, so what you have to do, how would you do this geometrically? Break it into a bunch of smaller shapes is correct. There's our bunch of smaller shapes. How do you find the area of a triangle? 1/2 the base times the height. So the base is 4, the height is 1/2. 4 times 1/2 is 2. Half of 2 is 1. Here is 4 times 1/2, which is 2. Here's 4 times 1/2, which is 2. Up here is 1. Here we go for 8 and 1. 8 times 1 is 8. And then here is 1 tall and 4 wide. So 4 times 1 is 4. Half of that is 2. So 1 plus 2 plus 2 plus 1 is 6. Plus 10 is 16 inches. Almost what we got here, but that is the area under a curve if they're straight lines. And we'll talk about area under curves in a little bit when it's a curve. A water cooler springs a leak and empties in 2 minutes of time. It only takes 2 minutes for all the water to come out. The graph below shows the water at the rate it leaks in gallons per minute. How much water was in it before it started leaking? Now, if you look up here and say, well, there was 6 gallons because 6 gallons a minute leaked out, and it doesn't work that way. Okay? So we started out it leaking at 6 gallons a minute, and as there's less pressure, it doesn't leak as fast of a rate. Okay? With the more water in there, there's more pressure on it, so it leaks at a faster rate. So then it slows down at the rate at which it's leaking. So how much water was in there? Well, if we look at this, in 2 minutes of time, 6 gallons a minute, 6 times 2 would be 12 gallons, right? But the triangle is half of that, so what's half of 12? And it happens to be 6 gallons. Now, it's not because it's leaking at 6 gallons a minute, but it worked out to be 6 gallons. Okay? All right, so we'll look at some problems like that where you have to break apart figures and figure out what is the area under the straight lines. Okay? Then we'll take area under curves. Now, to find area under the curves, we use what are called Riemann sums. And I'll do the easy way of Riemann sums today. In the olden days, we used to teach the sums and then show you what the Riemann sums were like. But I'll show you the easy way of this. Okay. We're going to divide this into 3 equal subdivisions from 0 to 1.5. Well, if it's 3 equal subdivisions, how wide are the subdivisions? 0.5. So there's a subdivision here, a subdivision here, and a subdivision here. Okay? Now, it says we're using a left Riemann sum. And when we use a Riemann sum, we're going to use rectangles. So rectangles and a left Riemann sum means we're going to start the rectangle where the function intersects the left side of the rectangle. So over here, it intersects it at 2. So this rectangle is only going to be 2 high because that's a left Riemann sum. If we used a right Riemann sum, this rectangle would be 7 units high. Okay? So for the second one, this rectangle is going to be 7 units high because that's where the left side of the rectangle intersects the blue line of the function. Okay? So this one is 7 units high. How many units high should the third one be? It should be 3 units high. Okay? Now, this is 2 times 1/2. This is 7 times 1/2 times 1/2. This is 3 times 1/2. Okay? 2 times 1/2 is 1. 7 times 1/2 is 3.5. 3 times 1/2 is 1.5. 1 plus 3.5 is 4.5, plus 1.5 is 6. So we just get it's just basically an estimation of how much area is under the curve. And our estimation for this is 6. Now, what could make this more accurate? More subdivisions. If we went halfway on each of them, so if we're still using a left Riemann sum, this one would be here, this one would be here, this one, left Riemann sum, would be here, this one would be here, this one would be here, and this one would be here. So if we use more subdivisions, we'd have 2 times 1/4 plus the height of this one is 6.5 times 1/4 because the width of them is 1/4 plus 7 times 1/4 plus 5 times 1/4 plus 3 times 1/4 plus 2 times 1/4. 6 subdivisions. So 2 times 1/4 is 1/2 or 0.5. 1/4 times 6.5, this is 13 halves, so it's 13/8. 13/8 is 1 point what? 1 5/8, so 1.625, right? 7/4 is 1.75. 5/4 is 1.25. This is 3/4, and this is 1/2. Why did I switch from fractions to decimals to fractions? I do not know. 0.75 plus 0.5. So if we add these up, 0.5 and 0.5 make 1. These add up to 2, so we're at 3. So 3, 4, 5, and then add these two together. Nope. No. So 5, and then 8, and then 3. So it's 6.385. That would be a little more accurate if we divided them up into a little more subdivisions. And we could even divide them up more and more and more and more, which you will discover that we will do in the future. But we're just using that many subdivisions right now. Well, if we don't have a graph, well, if we have just a function chart and we're told to use the left Riemann sum. Okay? So what you do is, this is the width and this is the height. And you're making rectangles, right? And I don't know what each of them are. I just drew a bunch of rectangles out. Okay? Using a left Riemann sum uses the left number for the height. Okay? The left number for the height. So how far is it between -2 and 0? How far is it between -2 and 0? 2. And how high is it? Well, it's at 7. So this is a 14 rectangle. How far is it between 0 and 2? 2. And the height is 11. So that makes 22. The width of this next one is 4. The height is at 2. So it'll make 8. The width of the next one is 3. The height is 8. The height is 8. And 3 times 8 is 24. And so we just add these numbers together. That's what a Riemann sum is. Okay, so that's 30 plus 34 is 64. Okay, Riemann sum. Here we got to put on our own subdivisions. There's 4 of them. Well, it makes it easy because there's our 4 rectangles. Now it says using a right Riemann sum this time. So we got to go to the right side and do it. Okay, so actually my drawing is a little bit off here. What's 2 to the -1 power? That is 1/2. Anything to the negative power goes to the bottom, remember? Come on. Okay, so that's 1/2. So the height of this one is 1/2, so this is 1 times 1/2. Okay, what's 2 to the 0 power? 1. So this is 1 times 1. 1 times 1. What's 2 to the first power? 1 times 2. What's 2 to the second power? 1 times 4. So we have 1/2 plus 1 plus 2 plus 4, which is 6, 7, 7.5 is the approximate area of that, using a right Riemann sum. Now, would a right Riemann sum be an overestimate or an underestimate? Overestimate, because the rectangles are above where the line is. Okay, if we'd use a left Riemann sum, it'd be like this, 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 and this. And that would be an underestimate. Okay, so an overestimate and an underestimate. Here's the last one that we'll do today. The area in between the h function and the x-axis from -2 to 4 using right Riemann sums with 3 equal subdivisions. How wide are my subdivisions? 2. And if it's a right Riemann sum, there's one of my rectangles. There's a rectangle. And there's a rectangle. Does everybody understand where I'm getting my rectangles from, the height of them?
Yes.
Yep, where the line hits the right side of a function. So this one is just 2 times 4, which is 8. This one's 2 times 6, which is 12. This is 2 times 4, which is 8. So it is 28 for the Riemann sum. Okay? So today you'll be estimating Riemann